In this tutorial, we're going to look at scaling data so that it gives the range of numbers that we want for various different reasons. Here, I'm using the CTL_in object to get data from MIDI controller 1 on MIDI channel 1. And if I turn the appropriate dial on the MIDI keyboard that's connected to the computer, I can see that I get a range of values from 0 to 127 in this number box here, which I'm just using as a way of visualizing what happens. So here are those values. 127 is the maximum and 0 is the minimum as I turn the dial back towards 0. So those numbers are coming from a dial on the MIDI keyboard. In this part of the patch here, I have a simple sound file player that I've built using the sfplay object. And here I'm using a floating point number box to multiply the signal's amplitude here, so that if I start playing back the file, I can adjust the volume of the signal like so. By changing the number in the floating point number box. With a value of 1, the sound file plays at its maximum amplitude, and 0 obviously gives me nothing at all. Now, one of the main reasons for using MaxMSP is that it allows you to control things in the way that you want. So let's suppose that I want to use my MIDI controller here to control the volume of the sound here. Now, at the moment, the MIDI controller, as we've just seen, generates values between 0 and 127. And here, I need values between 0 and 1 to control the amplitude of this signal. So I need to convert this range of values to suit the range of values that I need here. Here we have 0 to 127. Here we want 0 to 1, and so in this case, all I need to do is divide the value here, coming from the MIDI controller, by 127. I use the divide object, which is a /, give it the argument 127, the decimal point. I feed the output of the CTL_in object to the inlet of the divide object, use a flow num to visualize what's going to happen, and that gives me values in the range from 0 to 1 here. So as I increase the value of the MIDI controller to maximum, I get 127 directly from the control_in object. I then divide that by 127, which gives me 1. And as I decrease the value of the controller, we'll see that the final value reduces back down to 0 again. So I've now scaled that range of values to a different range of values. Notice that these values here are floating point values. They have a decimal point. So it was important to remember the decimal point at the end of 127. Now that I've done that, I can use this new range of values here to control the value that I send to the multiplication object here. That means that I can now effectively control the level of the signal using the controller on the MIDI keyboard, like so. So now we can see that the level of the control from the control_in object is changing, and as it changes, I'm scaling the values so that they're between 0 and 1, and now we're using the number that I can see here to multiply the signal and therefore control the volume. And if I turn this back down to minimum, the sound will disappear altogether. And of course, I could use the same method to control any parameter that needed to be in the range from 0 to 1. It's important to notice also that these two number boxes here are purely being used to visualize the numbers. In other words, I could actually delete them and this wouldn't affect the functionality of the patch in any way. I can still turn up the controller on the keyboard and adjust the volume of the sound, like so. In that example, we used the divide object to scale a range of values. I could also use any of the other mathematical operators to scale values in much the same way. Here are some mathematical objects which I've created already, so that if I multiply the data from this outlet by, let's say, 100, create another number box just so I can see the values that come out of that multiplication, we'll now find that when I change the value of the controller, I get a range of values from 0 to 12,700, like so. So every value that comes out of the control in is being multiplied by 100. I could then add to that stream of values. Let's say I add 50. I'm going to create another number box again so that I can see the values that come out of here. And now we'll see that at 0 I get a value of 50 here. So the controller itself is outputting a value of 0. By the time we get here, I get a value of 50, and as I increase the value of the controller, I have a range of values from 50 to 12,750 by going through two different mathematical stages with the original values. Now I've moved those two stages of scaling over here and tidied them up a little bit. And here I've added to the patch our original sound file player, but this time I've added a resonant filter using the reson object, so that now when I play back the sound file, I can change the filter parameter using this number box here, like so. So if I connect my new scaled range of values between 50 and 12,750 to this parameter, I can control the filter center frequency using the MIDI controller, like so. We've just seen that different ranges of values can be useful in different situations. And when you're using MaxMSP, you'll find yourself having to convert ranges of values all the time in the kinds of ways that we've just seen. Another useful object to know about in this regard is the zmap object, which I've created here. Now, the zmap object converts one range of values into another. So the first two arguments that you give it the range of values that you're starting with. So I'm still using the MIDI controllers, which we know gives a range from 0 to 127. So the first two arguments I give the zmap object are 0 and 127. The next two arguments give it the range of values that you want to convert to. So let's pick a random example of 7 to 2008.8. And now, if I connect from the outlet of the CTL in to the inlet of the zmap object, what we'll see is that as I adjust the setting on the MIDI controller, we'll see this range of values here increase from 0 to 127, as it did before, and this range of values here will increase from 7 up to 2008.8, like so.